Hi everybody, today I'm going to do two examples of rational inequalities. So the first one we have is 2 over x, which is less than or equal to 5 over x minus 4. And what's important here is that the right side is not 0, and we really need always to have the right side be 0, because the only way we can differentiate between positive and negative is we have 0. So we're going to start there by bringing the 5 over x minus 4 over to the left. So I'm going to have 2 over x minus 5 over x minus 4 is less than or equal to 0. Now that I see less than or equal to 0, we know we want a negative for our answer. So when we're looking at our sign chart, we want to pick the sign where the sign is negative. Having a fraction means I need to have a common denominator. And my common denominator is going to be this x times x minus 4. So to get us there, I'm going to multiply by whatever it's missing. So the x, the 2 over x, doesn't have the x minus 4, so I'm going to multiply top and bottom by x minus 4. And the 5 over x minus 4 doesn't have an x, so I'm going to multiply the top and bottom by x over x. So the reason I have to do the same thing top and bottom is because in actuality I end up only multiplying by 1. X minus 4 over x minus 4 is 1, x over x is 1, so I haven't change the actual value of the function, but I have been able to change the way it looks. All right, so I'm going to multiply across the top. 2 times x minus 4 is 2x minus 8. Pay attention to this negative sign in the middle, so I have minus 5x. In the denominator, I want to leave in factored form, so there's no reason at all to multiply that out. Okay, let's just combine like terms here. So I have 2x minus 5x. We can write that as negative 3x minus 8 over x minus 4 times x. So this is really our new starting place. This is what we're going to use to do our sign chart and to figure out this problem. So as we've been doing these problems, we've talked about what kind of things do I need to know. I need to know where are the x-intercepts, because that's a place where it could change from being positive to negative. And I also want to know where the vertical asymptotes are, another place where we could change sign. So the vertical asymptotes come from the denominator. X minus 4 is 0, x is 4, and the bottom x equals 0. So I have two vertical asymptotes, and I choose to put these as dashed lines when I get to my sign chart, and we'll do that on the next page. The x-intercept comes from the numerator, so I take negative 3x minus 8 and I set it equal to 0. That says negative 3x is equal to positive 8, and x is going to be negative 8 over 3. I will put this as a solid line when I go to do my sign chart. So to start my sign chart, I want to start with the number line. And I think about those three numbers that I have. I have negative 8 over 3. We'll put this over here. And then I have 0. And then I have 4. Remember, the 0 was a vertical asymptote. The 4 was a vertical asymptote. The x was an x-intercept. So when I'm going to make this chart, I'm going to draw a line to say it was an intercept. I'm going to do dashed to say that was an asymptote. And what that tells me is at the end, when I'm going to make my intervals, whether I make them closed or open is based on this. Let's put a reminder up of what was the thing we're trying to solve. Negative 3x minus 8 over x minus 4 times x, and that was less than or equal to 0. Now I'm ready to make my intervals. Negative infinity to negative 8 over 3, negative 8 over 3 to 0, 0 to 4, and then 4 to infinity. For each of these intervals, we're just going to pick a test point. Again, I always remind you that if it's helpful, if you're looking at negative 8 over 3 and you're not sure what it is, you may want to put it into your calculator. It says negative 2.167. That way you make sure you pick a number that fits in this interval. So let's pick negative 3. Then negative 8 over 3 to 0, I'm going to pick negative 1. 0 to 4, I'm picking 1, and 4 to infinity, I'm picking 5. So I just have to pick something in there. I'm going to put those numbers into negative 3x minus 8 over x minus 4 times x. And I like to do like each little individual part. Makes it easier than having to try to do a bunch of math in my head. So I'm thinking negative 3 times negative 3 is 9. 9 minus 8 over negative 3 minus 4 is negative 7 times negative 3. What do I care about? The top, 9 minus 8 is positive. The bottom, negative 7 times negative 3 is positive. This gives me a positive interval. So I did write a little just so I didn't have to like keep track of things too much, but I'm not having to come up with the whole answer. Negative 1 times negative 3 is 3, and I'm thinking 3 minus 8 on top. Then I have negative 1 minus 4, and then I have negative 1. So the numerator, 3 minus 8, is negative. Negative 1 minus 4 is negative, and then negative 1 is negative. 3 negatives is negative. I plug in 1, so I have negative 3 minus 8. I have 1 minus 4, that's negative 3, and then I have times 1. Numerator, negative 11, so that's negative. The bottom, I have negative 3, and I have positive 1. Negative, negative becomes positive. The very last one, negative 3 times 5 is negative 15 minus 8. 5 minus 4 is 1, and then times 5. So on the numerator, negative 15 minus 8, it's negative. The bottom, 1 and 5 are both positive, so 1 negative is negative. Back to the beginning, we said less than or equal to 0 here means we want negative numbers. So I want this one and I want this one. Because it says less than or equal to, we do have to pay attention to whether it's open or closed. And that's where these lines help me that I started with. So this line that came from the negative 8 over 3 says it's closed at negative 8 over 3, but then it's open at 0. That's the dashed line. Then union all the way over here to 4, I have a dashed line, so I know it's open, and it goes to infinity. I think we should try one more of those. So this one I have 5 over x minus 3 is greater than 3 over x plus 1. So same kind of start is that it's not set up to be greater than or 0, and I need it always to be related to 0. So we're going to move the 3 over x plus 1 first. So I have 5 over x minus 3 over x plus 1. This is greater than 0 now. And just like the last time, it kind of feels like cross multiplying, and if you want to do it that way, that works. I could do it that way this time. Say I have 5 times x plus 1 minus 3 times x minus 3. That makes it a little bit shorter. And then x minus 3 times x plus 1 in the denominator. Be careful with the negative, make sure you distribute it. So I have 5x plus 5, and then I have minus 3x, make sure you say that's plus 9, over x minus 3 times x plus 1. Again, greater than 0. Combining like terms, I have 5 minus 3, so that's 2x. I have 5 plus 9, that's 14, over x minus 3 times x plus 1. There's greater than 0. Again, we have that thing of what do we want to look for? We want to look for where would I have any kind of x-intercept and where would I have any vertical asymptote. X-intercept is always from the numerator, so 2x plus 14 is 0. Comes out to 2x is negative 14, x is negative 7. Vertical asymptotes I have 2. One from x minus 3 is 0, so that gives me positive 3. And 1 from x plus 1 is 0, which gives me negative 1. So just like last time, I have 3 places that I'm going to put on my number line. All right, so let's start with my real number line. And I have the 3 points to put on. I have negative 7, I have negative 1, and I have positive 3. Again, I'm looking for this negative 7 was a vertical asymptote, so I'm going to put a straight line. And then the negative 1 and the positive 3 were both asymptotes, so I'm going to go ahead and dash those. My intervals, negative infinity to negative 7, negative 7 to negative 1, negative 1 to 3, 3 to infinity. After we get the intervals, we always just pick some kind of point. So let's just try negative 8, negative 2, 0, and 4. But you can pick whatever you want. Let's remind ourselves what we were looking for. So we had 2x plus 14 over x minus 3 times x plus 1, and we have this strictly greater than 0. Okay, so that's what we're going to use down here in our sign chart. And we're just going to think about putting these numbers in. So 2 times negative 8 is negative 16 plus 14. I know that's negative. And then negative 8 minus 3, that's negative 11. Negative 8 plus 1, that's negative 7. So on the bottom, negative negative is positive. So this first interval is negative. Let's do it for the negative 2. Negative 2 times 2 is negative 4 plus 14. That's going to give me a positive. On the bottom, negative 2 minus 3 is negative 5. Negative 2 plus 1 is negative 1. Negative negative is positive, so overall positive. 0 plus 14 is positive. 0 minus 3 is negative. 0 plus 1 is positive, so this third interval is negative. The very last one, 2 times 4 is 8 plus 14, that's positive. 4 minus 3 is 1. 4 plus 1 is 5, so positive, positive is positive, so positive. Greater than, or just greater than 0, sorry, this time. Greater than 0 says I want positives, so I want this one and I want this one. Because it's strictly greater than 0, this one actually comes out to be easier. I don't have to think about what kind of brackets or closed or open intervals I have. It's going to be open because it's greater than. So that says my answer is negative 7 to negative 1, union 3 to infinity. So to check this, why don't we go to Desmos and just verify that we get the same thing, saying we get the interval from negative 7 to negative 1 and from 3 to infinity as being positive. And what I'm going to plug in is this modified, the 2x plus 14 over x minus 3 times x plus 1. Okay, so that's what I'm going to plug into Desmos. So I'm just going to call it y equals, and I'm going to put parentheses 2x plus 14, so that's the numerator, divided by, I have x minus 3 times x plus 1. Okay, and I'm going to kind of zoom in a little bit so you can see it. Maybe to help out, I could put x equals 3, so there's one asymptote, and I can put x equals negative 1, so I can see that one as well. It helps me break up the graph. We can change those over and make them dashed lines. That way they look a little bit better, and it helps our eyes view it. So we said the answer should be negative 7 to negative 1. So let me zoom in a little so you can see this negative 7 is where it crosses. And actually we could put the intercept of negative 7, 0. That really makes it pop, so you can see it was negative before that. It gets to negative 7 and it's positive until it gets over here to this asymptote, which was at negative 1. And then we also said it should be positive from 3 to infinity. So here's our asymptote at 3. I can see it's above, and as I zoom back out, I can see it doesn't cross again. So that's a nice way to check your answer without doing a lot of work, is just to go over and graph it. But again, graphing from Desmos, not graphing from us having to write it all out.